All right, end behavior of polynomials. This is the last assignment in the graphing section. So we have considered the polynomial function h of x is equal to x to the 6 minus 3 to x to the 5 minus 17x to the 3. What is the end behavior of the graph of h? Now down here we have a whole bunch of math jingo, or whatever you want to call it. I will talk to you about how to read this in a second. So let's go to my board. So what they're talking about is end behavior. End behavior, all it matters is what happens at the end of the graph. So as we go really far to positive infinity, is our graph going up or is it going down? As our graph goes to really far negative infinity, is our graph going up or is it going down? So let's take a couple of examples here. Y equals x, all right? And this is x to the 1, which actually is extremely important that we have a 1 there, or that it's odd. Okay? So all odds act the same way. So y equals x is going to have a graph that comes through the origin. I know it's not the origin, but it's supposed to be the origin. We'll make that obvious now. Okay? It's going to start down here at the bottom left and going to end at the bottom right. If we add a number to the front of that, all that does is it makes our graph go steeper. If I make this, let's say 2,000 in front, this is going to go really, really, really steep, still to the origin, okay? If I add a minus 4, all that does is it moves the entire graph down a little bit and it goes through minus 4, which is where this is at right now, essentially. Okay? So all that really matters is our leading term of our polynomial. So x to the 1, we're going to start bottom left and go to the top right. Well, I'm sure you've seen x squared before, okay? X squared looks like a bowl, or called a parabola, right? So every time we have an even, what you're going to learn is that our graphs start and end at the same place, okay? Now, if we want to make this opposite, all we do is throw a negative sign in front of it, and now our graph is flipped, okay? They still start and end in the same place. Now, if I were to make this from 2 to the next even number, 4, what's going to end up happening is it's going to come up, and there's going to be a couple of hitches, but it's still going to start, down here, start, and end in the same place. So once again, all we care about is the leading term of our polynomial, and that will tell us what happens at our end behavior of our graph. So let's go back to the question. X to the 6, okay, that's even. So they're going to start and end in the same place. And it's positive. So as x approaches infinity, h of x approaches infinity. So that means as we're going really far this direction, as x approaches infinity, our graph goes to infinity. And because it's x to the 4, we know, or x to the 6 actually, that is true. Okay? And then as x approaches negative infinity, our graph goes to positive infinity, which is also true again. So as x approaches negative infinity, our graph is going to positive infinity. And x to the 6 is going to look something like this. It's going to go down, and it's going to have a whole bunch of hitches, and then back up. Okay? So positive and positive. You can see there's actually 1, 2, 3, 4, 5 hitches. There'll always be one less hitch than the number up here. So like x squared has 1 hitch. Okay? X to the 4 had 1, 2, 3 hitches. Y to the 3 will come up 1, 2 like that. So 1 hitch, 2 hitch. And that's y to the 3. If it was negative, it would just be flipped. Just like that. So I know there's a lot of graphs going on this page. Or board. So our answer is A. Because they both go to positive infinity. Now if this were negative, our answer would be C. Negative infinity and negative infinity. They both go down. Right. So next question. So first thing we're going to look at is the exponent number, the leading term. Okay, so it's an odd. So they're going to be in different places. So A and C are automatically disqualified because they go to the same place. See, positive and positive, negative and negative. B, as x approaches positive infinity, goes to negative infinity. And as x approaches negative infinity, it goes to positive infinity. Well, this graph is x to the 7. So it's going to start down here and have 6 hitches. 1, 2, 3, 4, 5, 6 hitches, and then back up because it's positive. So as x goes to negative infinity, we go to negative infinity. As x goes to positive infinity, we go to positive infinity. So that one was going to be right here. Both go in the same place. Positive, positive, negative, negative. And nothing else matters. All this over here matters for where our zeros are, where our graph crosses the x-axis. But we're not actually asking that right now. We've done that before. So, even. So they're going to the same place. And it's negative. So they start negative and it goes negative. So starts negative, goes negative. C. Actually, this is back. I should have said that this is where it goes and this is where it starts. This is negative infinity is where it starts at. And then positive infinity is where it goes to. I said that backwards, but it's still the same principle. All right, last one. So same exact question, or not question, same exact answer. Because it's even and it's negative, we start from negative infinity and we go to positive, or sorry, and we stay negative infinity, but our x goes to positive infinity and our x comes back down. So we're coming from negative infinity and then we go to negative infinity. And we're done.